In this video, we'll be learning about equivalent and equal sets. So for this first problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set A, which is equal to A, B, C, D, and E. And then we have set B, which is equal to 1, 2, 3, 4, and 5. So a set that's equal means it has the same elements between the sets. So for example, if we had a set with 1, 2, and 3, and then we had another set that had 1, 2, and 3, these sets are equal. They have the same exact elements in the set. An equivalent set is it has the same number of elements. So for example, we can have a set like A, B, C, and then we can have a set like 1, 2, 3. They have the same amount of elements in the set. So we have 1, 2, 3, and then for the second set we have 1, 2, 3. So they both have 3 elements, or their cardinal value is 3. So therefore these two sets are equivalent. And then neither would mean they don't fit the category of equivalent or equal. So for set A and set B, we have 1, 2, 3, 4, 5 elements in set A and 1, 2, 3, 4, 5 elements in set B. So since they don't have the same elements but they have the same cardinal value, we can consider these sets to be equivalent. So that's going to be your answer. So for the second problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have X, the set of all positive integers divisible by 10 but less than 10, and Y, the empty set. So let's write out set X. So here, our elements are going to be positive integers divisible by 10 but less than 10. So integers can be negative or positive, but here we're looking at all positive integers. So that means that our numbers have to be positive and greater than 0. So our numbers are going to be greater than 0, but they're also going to be less than 10. So it's got to be in between 0 and 10 essentially, but this is not including 0 or 10. So we have to find a number in between here that's divisible by 10, meaning that it's a whole number whenever you divide it by 10, and it's in between those ranges. So if we try 1 divided by 10 is going to give us a fraction, 2 divided by 10 is going to give us a fraction, and we can go so on until we reach 9, the last whole number in our elements criteria, and we can do 9 divided by 10, but that's still going to give us a fraction. So no number fits this criteria, the set of all positive integers divisible by 10 but less than 10. There's no number that fits that criteria. So therefore, we can represent set X as 2 brackets, nothing in it, meaning that it's an empty set. And here we have Y, the empty set, which is exactly the same as set X. An empty set means there's nothing in between the brackets. There's no elements in the set. So if you notice, these sets have the same amount of elements. There's no elements. And it has the same cardinal value, which is, the cardinal value is essentially how many elements are in your set. So knowing that, we can say that these sets are equal. And that's going to be your answer. Now for this third problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set V, the set of vowels in the word elephant, and set C, the set of consonants in the word elephant. So we have to count the vowels in the word elephant for set V. So vowels are letters like E, A, I, O, U, and sometimes Y. So here we have 2 E's and we have 1 A. So the thing is, we do have 2 E's, but in a set, you never want to repeat your elements. Your elements are just all the things you can choose from. So essentially, we don't want to put 2 E's. We just want to put 1 E to represent that E is a part of our set. Now it may appear twice, but essentially it's just letters we can choose from or things we can choose from in a set. So we have E and we have A. Those are our two vowels in the word elephant. Now, consonants are letters that aren't vowels. So in set C, we have an L, a P, an H, an N, and a T. So we have L, P, H, N, and T. So if you notice, we have 2 elements in set V, and then we have 5 elements in set C. So since they don't have the same elements, and they don't have the same cardinal value, or they don't have the same amount of elements, these sets are neither. Neither as in neither equal or neither equivalent. And that's going to be your answer. So for this fourth problem, it says determine if the following pairs of sets are equal, equivalent, or neither. We have set A that has the elements January, February, March, and set B that has spring, summer, autumn. So set A has 1, 2, 3 elements, and set B has 1, 2, 3 elements. So they don't have the same exact elements, but they have the same number of elements. So since they have the same number of elements, this means that these sets are equivalent. And that's going to be your answer. So for this fifth problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set A. It has the elements 1/11, 1/12, 1/13, and 1/14. And set B has 1/4, 1/3, 1/2, and 1/1, which is just 1. So if we count these elements, we have 1, 2, 3, 4 for set A, and then for set B, we have 1, 2, 3, 4. So they have not exactly the same elements, but they have the same number of elements. So this means that these sets are going to be equivalent. And that's going to be your answer. So for the sixth problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set A that has the elements red, blue, and yellow, and set B that has green, orange, purple, and pink. So for set A, we have 1, 2, 3 elements in that set, and for set B, we have 1, 2, 3, 4 elements in that set. So for set A, it has 3 elements, and for set B, it has 4 elements. So they don't have the exact same elements, and they don't have the same number of elements. So therefore, these sets are going to be neither equivalent and neither equal. So that's going to be your answer. So for the seventh problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set A, and then we have our variable, which is going to represent each element in our set. And then we have our condition. N is a natural number. So a natural number is a number like 1, 2, 6, a million, 2 billion, and then all the way to infinity. It keeps growing on forever. And then we have set B, which this special n just represents natural numbers. So you may be quick to say that these two elements are equal because they have natural numbers in them. However, that's not the case. So for set A, it has 2 times n. So whatever n is in the set, so for example, let's start off with 1. Let's say n is equal to 1. So if n is equal to 1, 1 is a natural number, so therefore it's going to be 2 times n, which is n is 1, so it's going to be 2 times 1. So we have 2, and then if we move to n is equal to 2, we're going to do the same procedure. It's going to be 2n, which is 4, and then we can do n is equal to 3, and then we get 6, and then so on. So that's going to be for set A. So for set B, we have the set of natural numbers. So it starts at 1, and then goes to 2, and then 3, and then all the way to infinity. So if you notice, these sets, we don't have the same exact elements. So if you notice here, we have 2's for both sets, but for set B, we have a 1, but set A doesn't have a 1. So these sets, we know for sure, are not equal. So are these sets equivalent? Do they have the same cardinal value? Yes, they go on forever, but if you notice, A is going to be counting by 2, so it's going to essentially miss some of those odd numbers. But for set B, it's not skipping no whole numbers. It's going to be odd or even numbers. So knowing that they don't have the same exact cardinal value, yes, they might go on to infinity, but they are not counting the same amount. So therefore, we know that they're not equivalent. So the answer is going to be neither equivalent and neither equal. And that's so for this eighth problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set A, which has -2, -1, 0, and until infinity. And then we have set B, which is equal to 4, 6, 8, and then to infinity. So this is similar to the previous problem. So we have set A, it's going to be -2, -1, 0, and then to infinity. And then we have set B, which is going to be 4, 6, 8, and then until infinity. So we know for sure that these sets do not have the same exact elements. Set B does not have a -2, a -1, or 0. So we know that these sets are not equal. Now, are these sets equivalent? Well, if you notice, A starts at -2 and it just follows a pattern of counting each whole number until positive infinity. Set B is skipping by 2 or just counting even numbers all the way to positive infinity. So knowing that they're not going to have the same amount of elements in their set when they reach positive infinity, we know that these sets are going to be neither equivalent and neither equal. So that's going to be your answer. So for this ninth problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set X is equal to Leonardo da Vinci, Vincent van Gogh, Pablo Picasso, and Claude Monet. And set Y has the elements William Shakespeare, Jane Austen, Ernest Hemingway, and J.K. Rowling. So let's count our elements in our set. So for set X, we have 1, 2, 3, 4 elements in our set, and for set Y we have 1, 2, 3, 4 elements in our set. So they definitely do not have the same exact elements in their set, in those sets, but they have the same cardinal value or the same amount of elements in both sets. So therefore we know that these sets are going to be equivalent, and that's going to be your answer. So for this 10th problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set X, which is equal to an empty set, and we have set Y is equal to null notation. So the null notation just means 0, or nothing is in it. So knowing that, we have set X, which is an empty set, so that means that the cardinal value is 0. There's no elements in our set. And then we have set Y, which is the null notation, which is just a different way of saying that your set is empty and that your cardinal value is 0. So since they have the same amount of elements in each set, they also have the same exact elements in each set. They have nothing. So therefore, these sets are equal. And that's going to be your answer. So for this 11th problem, it says determine if the following pairs of sets are equal, equivalent, or neither. So we have set X is equal to red, blue, and yellow, and set Y, which is equal to circle, square, triangle, rectangle. So for set X, we have 1, 2, 3 elements, and for set Y, we have 1, 2, 3, 4 elements. So they don't have the same exact elements, so they're definitely not equal, and they do not have the same amount of elements, so they are not equivalent. So that just leaves us to neither. So these sets are neither equivalent and neither equal. And that's going to be your answer.